This is a full tutorial on how to build one of my Nano drones. I'll be going through the whole process, soldering the motors on, configuring the flight controller, and configuring the O4 Lite. I'll also be showing you how to update the ELRS receiver. Currently the O4 Lite isn't really playing nice with the receiver, and it sometimes interferes with the RX signal. You can improve the reliability by updating the ELRS. I'll have a full list of recommended parts in the description. To those of you with ADHD, please watch this video all the way through before you start doing this. I also want to apologize in advance. I am doing this with insomnia, so I may make some stupid decisions. To take off the connector first, and then to desolder each individual pin. Take some pliers, grab the connector, and just wiggle it, and it should pop off. Get yourself some solder, get yourself some solder wick, get yourself some flux, get some pointy tweezers, and get yourself some wire snips. We're going to remove what remains of these pins on these connectors. I have a horrible setup for recording video, and that is not likely to change for a while, so I apologize in advance. Press the soldering iron into the pad and into the pin. Don't try to heat the pin directly. You want to aim for the pad. You'll start to see the pin move, and once it moves, you can just snatch it out. Be careful that you don't accidentally bridge any of the legs for this ESC. Try to avoid having the soldering iron on the pad for too long. You can end up damaging the board if you apply too much heat to it. Apply a little bit of solder. Once that takes, grab it, reheat it, pull it out. Apply a little bit of flux, and we're going to prep each of these pads. You don't want to put too much solder, just put the solder on it and snatch it off. For the middle one, you actually want to make sure that the solder goes all the way out to the side. So the easy way to do that is just take this, hold it, and flick out, and now it's nice and clear. That'll make it easier to solder to later. It is very easy to bridge these pads together. So you want to take a good look at it under a microscope or under a magnifying glass. Make sure the pads aren't bridged together. Next side. There we go. Try to avoid having the soldering iron making contact with the board for too long. Put some solder on that pin. See that solder flow onto the pad and the pin? Now you're good. Now you should be able to just easily tap the pin, pull it out. It should be just that easy. A good thing you want to make sure that you look out for is sometimes little pieces of solder will break off and they'll kind of just float around the area. So you want to be careful of that because that can short out not just the pads, but the ESCs or anything else. Always inspect your work. So now we're going to start with these motors. So you want to cut these motors, the motor wires about 14 millimeters. You can make them a little bit shorter. If they're a little bit longer than they need to be, then if something goes wrong, I could just cut off a little bit extra and I'll be fine. But if something goes wrong with the soldering, then I have to solder on an entirely new wire, and that is annoying. So what I usually do is I make the motors longer than they need to be, and I just twist them up wherever necessary. Twisting the motor up helps to shorten it. Also, you're going to need to remove this heat shrink. You could use wire snips for that. Just get under the heat shrink and pull. Try to avoid cutting it. If you apply too much pressure, you just cut straight through the heat sink and it'll just slide off. If you end up cutting the wire a little too much, then what you do is hold the wire firmly at the midpoint, get some tweezers, and then just pull little bit, and sometimes you can pull the insulation back onto the wire. Then you want to twist up the ends of the wires, that way they're not frayed. Because if they're frayed, then when you go to solder them onto the motor, you might have strands that are touching multiple pads, and that is very difficult to see, and you could end up damaging the ESC doing that. And ideally you want to cut back about 1.5 millimeters of insulation. Now we're going to tin the ends of these motor wires. Different people are going to have different ways of doing this. I just take the motor, bend the wires up a little bit, fray them out a little bit, and then I'll just place them under the scope. And just lightly touch each motor wire. You don't need a crazy amount of solder just to keep the wire from fraying. You don't want a blob of solder on the ends of the motor wire. The way I install these motors, I have the flight controller upside down, and I just run each wire direct to the pad. There's still some residual flux left on the flight controller from when I prepped the pads, so I'm just gonna reuse that and just give each motor wire a quick tap. And there we go. Not too much solder, not too little. So you want just enough just to keep a good bond. Okay, soldering is done. Now to clean off that excess flux that's on the board. Don't just leave it there, because then it'll attract dirt, debris, and that'll possibly cause shorts or increase the resistance, you know. A good way to remove flux is to just apply some heat, and that'll activate the flux. And just get yourself some alcohol, Q-tip. Okay, let's reactivate that flux. Don't apply too much heat to the board. You don't want to melt the connector. And then just lightly scrub with the Q-tip. Be sure not to rip these little capacitors or resistors off the board. Okay, so get your frame. Make sure the countersunk is facing up. Put these connectors through here. Alright, if you want to install gummies and you don't want to suffer, then just get yourself a basic tool. This honestly works better with a hex. Install the gummy like that, sideways. Make sure it's facing inward. And then you just want to poke it until it goes through the hole. Try to avoid stabbing it. And there you go. That's why it's better to use a hex, because a hex is blunt, unlike this where you can stab it if you're not careful. Just angle that to the side, poke it until it goes through. Also, when you connect this connector, make sure it's all the way in. It does take a good amount of force to get this connector seated. Otherwise, it might pop out and then you'll have video issues. Alright. It doesn't matter what side you pick. The frame is completely symmetrical, front and back, side to side. It doesn't matter. So, just run these cables up through it. Put this through here. Alright, I need the screws. You can get the screws from this kit. These are the ones that I recommend using, but I used up all of mine, so I'm just going to be using these and cutting them a little bit. You'll see what I mean later. Line that up. Make sure that it's in between. Put that through there. Put this connector through this hole. Put this through here. It's a bit easier to do this without the motors connected. If you screw the motors down, then it limits your ability to manipulate the flight controller. So screw the motors down later. Once you get the screw on there, you can just hand tighten that down a little bit, just to keep the screw from flying away. Just enough force until you start to feel resistance, and then just back off. You don't want to crush the gummy. You'll notice these screws are a bit longer than they need to be. That's what I mean when I say just cut them off. These are plastic, so it's very easy to cut them. Alright, now for the motors. And as you can see, these are a bit longer than they needed to be. So what you do is take that, twist it, and then just align it how it needs to go. Line up one screw and tighten it down. Don't tighten it down all the way, because then if you're off, you might not be able to align the other two screws. So just loosely tighten the screw down. And these screws could be kind of annoying because they're non-magnetic. So here's what you do. Put the screw on there, hold it with your nail, and then just guide it in place. Be mindful of how much torque you're applying to the screws, because these are all plastic and you can strip them if you're not careful. Okay, now we're on to the O4. Get rid of the stock antenna. Just wiggle it and move it. Be careful with these connectors. They are fragile, so don't just, snatch it off. Be careful, because if you damage these, they are annoying to solder on. On analog, there is a noticeable, loss of signal strength, but on DJI, not really. You won't need this. These come installed with the air unit, but you don't need it. The Beta FPV sends you one when you buy their flight controller. Alright, hold on. So I want to install these gummies. These are actually shorter gummies than what DJI provides. They provide you like these taller gummies for the flight controller. Where are they? Here they are. Yeah. The ones they give you are a little bit taller. I'm using, traditional flight controller gummies, which are just 4 millimeters tall. Just take these gummies and just cut off the excess. Since it's just holding the O4 in place and it doesn't really need, the shock absorption that an actual flight controller would need, you just cut it to 4 millimeters and then you should be good. The O4 camera, put it through this hole, take the air unit itself, and you want to make sure that it's upside down. That way you can easily reach the connector that's on the other side. If you run into overheating problems, you might need to take off this sticker. Now we're going to take some 6 millimeter screws. You could just push the screw straight into the assembly on both sides. Be very careful tightening these screws down. They are extremely susceptible to stripping. So for the O4 camera itself, this is the camera guard. Just put the camera in. It should slide in relatively easily, but of course you want to make sure that you're not getting these little chips stuck on this. So just push the camera in, hold here, push here, and that's how you apply pressure. If your nail slips, you might accidentally knock these components off, and the same goes for this side. So that's why I held it the way I did, by the lens and not by the PCB. For the connector, push that flat down and to the left. This little groove is for the connector. This wraps around all the way and gives the camera a little bit of protection. Bend this connector like that. For the camera holder, you could just apply some pressure and these screws can go in like that, and then you could tighten them down a little bit more later. Before we route the camera connector, we're going to properly install the VTX. Get some more of those screws. For these, this is TPU, so you can honestly just push the screw straight through it, and that should be fine, and then just tighten it down a little bit extra later on. And there is enough tension to keep the screw in without having to tighten it down with a nut, but you can if you want to. You just have to use screws that are a little bit longer. And then once the screw is through, just tighten it down a little bit more. You can see it's kind of sticking up a little bit. You don't want that. You want it to be nice and flat. These screws are longer than they need to be because I didn't have the right length screws. So I'm going to cut 2 millimeters off. If you're using the nylon nuts, then you could just keep it as it is and then just screw the nut on down into it. But these holes on the bottom are undersized so that the screw will hold in place. For the antenna, there's this little hole that you just route it right through. There we go. Adjust the camera a little bit. And now it's time to route the camera. Make sure the connector is in its little slot. You want to be gentle with doing this. You want to make sure this connector doesn't have any slack here and just pull it. And the same goes for this. Just pull and then squeeze them together. Once they're together, you just route it underneath here. I strongly suggest not using pointy tweezers for this. You don't want to accidentally stab the cable, and that is in place. Remember, I did not tighten these screws down. I just pressed them into place. Now is the time to tighten it down a little bit more for some extra security. Next, we're going to install the props. I install mine going props out, which means the edge of the prop spins this way and is facing out. Make sure you don't have these upside down. They will work, but you'll just have horrible efficiency. So you want to have them in their upright state, installing upside down onto the motor, and install them as much as you can, and then take the drone and then just press them down. Press them down firmly. Sometimes you'll need to apply a lot of force to do this, and you don't want to crack the frame doing that. So you want to make sure that all of these wires are out of way of the motor bell and they are not rubbing on the motor bell at all. Alright, for the last two props, I'm leaving them installed halfway on, and that's like that on purpose. You'll understand why later. I am also leaving this detached for now for similar reasons. You'll understand later. Here's all the hardware you're going to need. Once you finish the drone, make sure this is unplugged for now. You'll need a battery. You'll need a programming cable, Type-C. I am doing this for the Radio Master Pocket and the DJI N3 goggle. The software you'll need is Betaflight Configurator. You'll need DJI System 2. Make sure you get the Consumer Drone series. If you get any other series, it might not recognize the O4 Lite. Do not open all these at once. This is just for presentation. And you'll need ELRS configurator. You also may need ESC configurator. You may need to access the ELRS web portal, which is 10.1.0.0.1. We're going to start off simple, making sure the motors are all aligned in the correct orientation. Close out all the other programs because they might interfere. Also turn the radio and the goggles off because they also might interfere. I'm just going to close out this browser. Install your battery. You don't need the air unit connected for this, so just leave it unconnected, otherwise it's just going to overheat. The reason I installed these props halfway on is so they don't collide with the connector. Connect the flight controller, the computer should pick it up. If it doesn't, then you might have some issues with drivers, and you should hear a little chime. If you don't hear a little chime, then something might be wrong with your flight controller. Go to motor direction, make sure this connector isn't in the way of the props. Onto motor direction. What I just do is I just press this button. The airflow should be pointing towards you for each one of these. Just treat it like a little fan. Hold it toward yourself. Do not do this with a larger quad. Unplug the battery since the battery is no longer needed. You only need the battery in order to engage the ESCs. The ESCs will not work in any way, shape, or form without the battery connected. We're still going to leave these props as they are just for now. Up next is binding the controller. The way I'm going to recommend doing it is by sending a binding phrase. So let's close that window, plug this in, turn your radio off. When you're configuring any settings for ELRS, don't have the radio on. It might interfere with the process. Go to Wi-Fi, and you're waiting for Express LRS to pop up. Could take several minutes. I don't recommend having the battery plugged in because then you're just wasting battery for no reason. Alright, Express LRS is up. We're going to connect to that. And once you connect, your browser should pop up and it should try to connect you to the Express LRS webpage. Sometimes it fails and redirects you to MSN. I have no idea why, but if it does that, then just type this IP address 10.0.0.1 into Express LRS and then you're good. Now you want to set a binding phrase and then click save. But that is not all that we're going to do. We want to update Express LRS to Express LRS 3.3.6, if I remember that correctly. This is the board that you need when you're flashing the firmware. Unplug that. Express LRS configurator. Okay, it was 3.6. That's the most current version of Express LRS. And for device category, Betaflight 2.4, and for the device and just paste, and that'll be the board that you need. This is honestly the same if you want to update for Pavo 20 Pro. Even though the board looks different in the web portal, it is the same board. So you want to click that, click Wi-Fi. Here you could set a binding phrase, and then you want to click, and then just leave all this as is, and just click build. And that'll give you a file that you could use. Cut this file, put it in your downloads folder or wherever you want to put it, on your desktop, whatever. Now you can close out the configurator, connect back to Wi-Fi. Alright, so once it loads, go to update, get your bin file, drag it, or browse for it, whichever, and now it's updating. Don't touch it, don't mess with it, just watch the progress bar and don't mess with it. Pay attention to the lights. Update complete. Wait for the LEDs to resume blinking before you disconnect it. It is blinking. It's good. So we're going to disconnect that.
Welcome to HTX. Weather warning. Switch warning.
For ELRS, you always need to power up your controller before you power up the drone. Otherwise, it won't recognize the drone. That's just the way ELRS is, unfortunately. Okay, so plug that in. Throttle down. Let's see if it'll arm. Okay, it started breakdancing. That's perfectly fine. Unplug this.
Telemetry lost.
If it starts breakdancing like that, then plug it back in. Go to Betaflight, motors, invert, save and reboot. After inverting the motor direction, let's see if it works.
Telemetry recovered.
I'm going to line of sight this and just put it in horizon mode. Okay, we're good. If your drone is still acting crazy, make sure the props are exactly as I have them here. If the craziness persists, then close Betaflight, go to Chrome or whatever browser, escconfigurator.com, plug the drone in, plug the battery in. You need that battery to activate the ESCs. If it doesn't pick up, then click port selection, Betaflight. Make sure Betaflight is not open or any other serial based program, because it will hijack control. Now click connect, click read settings, and look at your ESC. If it doesn't work, then you might need to reverse 2 of your ESCs. So just pick either 1 and 4 or 2 and 3 and reverse them. And hopefully that will fix your issue. Now we are going to activate the air unit. You will not be able to activate the air unit unless it is powered by the drone's battery. The cable by itself is enough to update it, but it is not enough to activate it. Plug in the battery, start up DJI Assistant, plug in the drone. Storage came up, close that. Now it has the option to activate. I advise getting yourself a little cover for your goggles. These things scratch very easily. Alright, turn on your goggles. Now we're going to bind them to the goggles. Make sure you have the option for loading the DJI O4 air unit. If it's set to any other option, like O4 Pro or Avata or Neo, then it might not acknowledge this and activate. So we're just going to hold that button. And now that's in bind mode. Plug this in. And then once this turns red, we're going to tap the button that's right here on the edge. Wait for it. And that's red. Tap that button. Now it's blinking red. Now it's trying to connect. Connected. And now we have visual. ELRS is bound to the radio. The air unit is updated and bound to the goggles. The motor configuration is done, so now it's time to fully seat these props down. Now that way everything is flush. You may need to adjust the switches for your beeper depending on how you like them. I like to have this for turtle mode and this for the beeper. If you want to set it up that way, plug the drone in, unplug the O4. If you want to replicate those settings, and if you want to test the beeper, you're going to have to plug in the battery because the beeper comes from the motors. I have beepers set to UX3, and that is the value. And I have flip or turtle mode, or whatever you want to call it, set to UX4, and that is the value for that. And then you just click save. The only thing you really need to change after this is the craft name. And I also like to have my voltage dead center of my screen. That way it reduces the chance of me killing a battery. Save that. Some more things I advise changing. Turn that on, turn that on. These two will help prevent, voltage sag. You won't feel it as much with these two on. It'll kind of automatically compensate for it. Now we're going to turn on the goggles and give it a first little test flight.
Telemetry recovered.
That concludes this project. Thank you guys for watching.